My name is Michael Davis, and I am here to call bullshit. The open source security is based on the concept that the source code is open, available, that numerous programmers around the world are reviewing your code and letting you know about the vulnerabilities in it. Bullshit. First, a word from my sponsor. They won't even claim the body. Okay. I am here because I believe in the open source movement, open source software. I am here because I believed blindly. I ignored my education and my experience, and I believed. I had a customer ask me, oops, let me know if you can't hear me because I'm bouncing around. I had a customer ask me for a recommendation on a tool to sanitize hard disks so they turn computers in. I said there's a great open source tool out there, Derek's Boot and Nuke, DBAN. He said, can I trust it? I don't know. How will I know? We said we would look at the software and make a recommendation on whether we could trust it or not. And so we took on the task to review software for DBAN and other open source solutions and make a recommendation on whether it can be trusted or not, what kind of review had been done. We couldn't find any evidence of any reviews for DBAN or the other tools that we had found. One of the primary hurdles we faced in doing our review was a lack of developer documentation. What we found was high-level functional description, why you'd want to use this program, and in most cases, commented source code, and nothing else. So essentially, if you're trying to understand the program, you have to really understand the program. So I'm here. There are a lot of reasons why we need to review open source security solutions. I'm here focused today to talk about the lack of developer documentation and why we need it and who can benefit from that. And I'll talk about two different communities who need that kind of information. After presenting some benefits and hopefully getting some buy-in, I want to discuss the difference between functional, which is what most people look at when they talk about security, versus assurance, confidence in what's being done. I'm going to use a model. I am not endorsing common criteria. I am just using the assurance piece of it as a model to discuss how to gain confidence in an open source security solution. Then I'll be focusing on the development piece in depth, what I see as a path ahead, and my limited view of the path ahead, and then I'm going to wrap it up. First thing, confessions. The title of the presentation was meant to antagonize, to draw a crowd. For a Sunday afternoon, I think I got it. As I said, I am a believer in open source. I use the solutions when I can. I recommend them when they can. I was just challenged and wanted to share my frustrations. One of the things that seems obvious, but maybe not so obvious, is just because the source code is available does not mean it's being looked at. In some cases, this is true. In some cases, what people think is being looked at is just a spotty, not comprehensive look for exploits or vulnerabilities that can be exploited, ignoring other vulnerabilities that could be exploited but were more difficult to develop. So we need to appreciate that there's a difference between just having the source code available and actually having someone look at it, preferably someone other than the person who wrote it. And there's some challenges to that. A recent survey of what's on SourceForge showed that about 98% of the software out there has one or two developers on it. And I'll highlight an issue with that later on. This problem, not documenting how you develop the software, is not an open source problem. It is a software development problem. It doesn't matter whether you're commercial or open source. You face the same issues. You just have some abilities to solve them different ways. I'll tell you up front, I think the open source community may address this faster than the commercial world can, simply because of our willingness to share lessons learned, the pain we felt, and try to have other people not experience that same pain. Yes.
Commercial software world, documentation that is the last thing to develop the product. And people always focus saying, I speak from experience.
Yes.
There's a whole different talking about. I know that.
Yes.
And so it's self-sufficient, everybody's happy.
Okay. And that is one of the things I'll highlight again later in the presentation, but commercial software, the schedule's primarily driven by a marketing schedule. It's a business decision when to ship, not a technical decision. This is different than the open source community, which tends to ship when they think it's ready. A different philosophy, different pressures, different motivations. And software lifecycle. We need to respect that software is never done, just shipped or posted. It is a continuous process to improve that software. The other thing that that isn't appreciated, and this is going back to the one or two developers on a team, is the development teams have life cycles of their own. On larger teams, you'll see people come in and then roll off. And so we need to look at that transition. Most of the mistakes that are in software were not put there deliberately. They're screw-ups, all shits. Whatever you want to use, they're there because someone wasn't thinking at that moment about that particular issue. You'll also find where we discover new vulnerabilities that we didn't really think about when we were doing reviews beforehand. So a review 5 years ago might not have thought about looking for integer overflow situations, where if you're doing that today, you might do that. Maybe you should. Repeating again, the status quo for most of the open source projects is a high-level functional description, why you want to use the software, and then its comments of varying qualities in the code itself. There's typically no supporting documentation in between, except for the occasional user guide. There are some exceptions. Mozilla is probably one of the best that I can point to. It's a larger team, obviously, so I'm somewhat cheating. But they have a site dedicated to developer documentation and cover it so you can kind of wade yourself in. Not suggesting that all projects need that level. The other one I heard today was Tor, which was interesting because the Onion router or routing, I can't remember what the R was specifically, they have design documentation, and that documentation allowed the porting from Tor, which I think is written in C, to be written in Java over in Germany, the JAP group, I forget what the acronym stands for. Why do we want to do developer documentation? There are two distinct groups who need this documentation. The first is the development teams themselves, and it's kind of hard when you're doing the solution yourself to think that you need documentation for yourself. But if you go back to my point about the teams grow, people roll in, roll off as they have different needs, you can see that having information about design decisions recorded somewhere would be extremely useful. If you have development documentation, you lower the bar for project participations. You can bring more people in because they can understand what your tool does and how it works easier. I have to put out a word of caution. I was introduced to a term that I had not seen before. It's a concept known as a net negative programmer. And that basically means that at the end of the day, this individual has done more damage than good, no matter how many times you sit with them. So you want to lower the bar, but you can't do it blindly. In that development documentation, you're going to communicate design decisions. One of the more important things that you might not intuitively think to document is the alternatives that were considered but not implemented. Because this becomes very good down the line when someone says, oh, I have a great idea, let's do it this way. If that path was previously explored, you have a record, and if the team members have changed, you're able to see that. Those benefits all benefit the team that is developing the open source software. There's another group who's interested in looking at this software, and those who are trying to say, yes, we can trust it. Not just for not just the function, but we can trust it. We need to gain confidence that if it says it does A, it does A, but we also need to gain confidence that it doesn't do B when it's not supposed to. And that's a much more difficult task. It is not a trivial task. It is, well, never mind. Yeah, I think I'm speaking to the choir on that point. We need to separate two concepts which may or may not be well understood. One is, what is a functional requirement versus an assurance requirement? A functional requirement is, this is what it does. it does not imply any confidence in how much we should believe that it's going to continue doing that. This is contrasted with an assurance requirement that says, this is how I can show that you should have confidence it's going to do whatever I said it was going to do. Yes. Depends on your model. There are assurance requirements that cause functional requirements to be created in the common criteria model. I guess that's the easiest way to say. You can have, from my perspective, it's easier to separate the two mentally. I want to talk about what it does, and then I want to talk about what I'm going to do to give people confidence it does that and doesn't do anything else. As I said, this is not an endorsement for common criteria. It's a model I'm familiar with. They have a vocabulary to define what the thing does. They have a vocabulary to describe what assurance requirements are there. They have a methodology for evaluating someone who says this is what I want to build, and for someone who says I built this. The only piece that I'm grabbing right now is, and I'll caveat it, most of the assurance requirements. And the reason I'm grabbing that is just to have a model we can look at. The majority of the assurance requirements are the ones here, and the one I'm skipping is the concept of assurance maintenance, which is a bit overwhelming at this point. And so we'll look at configuration management, delivery and operation, development, guidance documents, lifecycle support, tests, and vulnerability assessment. My focus, again, is on development and developer documentation. And what I'll try to do is point out for each one of these how we in the community have tried to solve the particular aspect. And the only one I'm going to talk about a little more in depth is the development. Configuration management. Vocabulary first. The definitions that I'm grabbing here come right out of common criteria, and you're going to need to know 3 definitions as we go through this. The first one's TOE, targeted evaluation. Just read that as your software, because that would probably be the correct answer. When you see TOE security function, that just means the security functions that your software does. And that's differentiated from other functions. And then if you see ST, that's security target, and that's just the statement of what is about your software. For configuration management and managing the versioning, the changes that are made to open source software, the de facto standard is CVS. That seems to be one area where we get it. We have versioning control. We have a way to control who can make changes. We seem to be on track with this one. Delivery and operation. This deals with having your software go out, get installed, and come up and operating in the way that you thought it would come up and operate. Right now, the software is typically distributed from a website. The concern you could have is that the software could be swapped out, compromised, etc. The way a lot of organizations have dealt with that is they pull the software down to a mirror, and then they wait a few days because people care about their software. If your web server that was providing software got Trojaned, you'll know about it rather quickly. The word will get out. If they see that, they know that their internal copies got copied. Yes? Okay. The issue with MD5 is it is just the hash. Okay. With PGP, you actually have someone signing the hash. So if you have software on a website, I'm going to put my Trojan software and my Trojan MD5 up there. Okay. You can see the difference. Some people don't even have the MD5s up there. From my level, MD5s provides a low level of assurance. You have some confidence it hasn't been compromised, but not a great deal. You know that if it was compromised, where it was compromised, the web server that's providing you the signature and the software. With PGP, it's a little bit higher. There's a whole big area to get into, and I do not see a lot of widespread use of digital signatures to assert that the code is correct and came from who it was supposed to. Development. This is the area that I'm going to want to focus on, and the area where we have, I'll use the term, the least documentation. Because what we need to start with, in theory, is a high-level description of what we want. That's going to be turned into requirements that get turned into security functions. That's the TSF. And then we're going to take those requirements, we're going to design some software based on modules or some sort of subgrouping, and we're going to explain how, as we go down each level, all the way until we get to the source code, where that function is being handled. And so you can see right now we have high-level functional description and source code. Without really getting to know the code, you're having to jump from the top to the bottom, or more specifically, you're starting at the bottom, and then once you understand the code, you'll understand how they implemented that high-level function they're describing. Guidance documents. That's a variety of guidance documents are out there. In general, user documents are common. Administrator documents, common. And then some organizations have technical user. Some projects have additional ones. And this is just, I'll use the term use documentation, how to run the software. Lifecycle support. It says ad hoc, but if you look in the middle of the paragraph, you'll see flaw remediation. That is one area where you cannot argue that the open source community has a real advantage, because when a vulnerability is identified, the ability to pull people in, especially if you say help, has no parallel in the commercial world. So that is one area where we do have an advantage, and it depends on the size of the project, is your ability to pull things in. Yes?
The company has a really bad flaw in product. They will shut down. They'll charge it. They're ready to fix the original problem. It's a serious one. So a large company does have those resources should they choose to use them.
And that's the key issue. Should they choose to use them?
Small companies, they don't have any margin.
Yes. Okay. Let's see. Testing. You can argue this both ways. You could say that we release the software, we let it to run, we allow people to feedback when it doesn't work, and that's our test model. You may have some projects that are extremely well organized, and they define test cases, and every time they make a change, they do regression testing to ensure that they haven't broke something else with that change. I did not see a lot of cases where that was there, or that they provided the test cases that they used or the results from those test cases. Using the common criteria model, that kind of evidence would be provided to some sort of reviewer to show. So going back to the assurance team trying to say, yes, you can trust this, that information isn't available, the test cases and the results from those test cases. Let's see. Vulnerability assessments. Really interesting topic. It's where you're looking at your design and you're saying, how can someone screw with me? And then you document how they can't screw with you based on how you thought they could screw with them. The philosophy called abuse cases is the one I was introduced to kind of explain this. I haven't seen a lot of that kind of formality in the open source community. This is not to be construed with what's going on where you have people looking for holes that they can write exploits against. That's different. This is more, I'll use the term, internally driven versus someone trying to punch holes in it. If folks are interested, this sounds like something that could be worked on and built into a presentation for next year. But this is this year. So let me talk about development documentation. We need to understand what is the requirement. What am I looking for? What is it? From my perspective, I represent the teams that would look at open source software and say, yeah, we can trust it. So what we would be looking for is two things. One, some document that captures the design philosophy, and then this tracing down to the software, and what tools are available. Before I start digging into that, I had someone look at my presentation who was involved in a couple major open source projects and gave me some insight into how not to do documentation, developer documentation. And so before I get into how I think it needs to be done, let me just emphasize that I'm acknowledging that there are a lot of ways to screw this up, a lot of really painful ways. Individual worked in an organization where the documentation consisted of source code, comments, which was pseudocode and only the pseudocode before the actual code. It was so obvious to be useful and annoying. From a paper written on IC Sharp's website, Bernie Spaduto, I mispronounced the last name, wrote a paper in 2002, which kind of amazes me. It was on how to comment your code well. I was introduced to commenting back in 1982 in my first programming class, and it just surprises me that we're still writing how to write comments well in our source code. Obviously, we haven't fixed that, and that helps me manage my expectations not to expect everybody to run out and develop our documentation tomorrow. Baby steps. One of the things that he emphasizes is don't bury comments in your source code that have to do with configuration management issues. That says, I did this to fix this. He recommends that goes up in front so that you have a versioning control for the files. It amazes me. Don't include comments that address the obvious. Apparently, some organizations have a real issue with this where they want everything commented. This reflects an earlier comment. Don't leave the design and the code out of sync. There may be times that you realize that you need to fix something that doesn't match the design. At the end of the day, they need to match. Don't wait until the end of the project where the code's written to write design documentation that explains how you ended up with what you got. They need to be kind of kept in sync. Most importantly, do not assume that well-commented modular code is enough. If you're looking for your project to be survivable beyond the one or two developers that are supporting it, that is not enough. You need some more documentation so that more people can pick up and run with your solution if you can't. So what am I looking for? We need in the documentation, development documentation, to understand the flow and the purpose of what is there. It doesn't help us run the software any faster. It doesn't help us configure it. This is extra documentation I'm asking for. I mean, years ago they said put comments in your source code. Then they said make user guides. Well, now I'm here saying and make developer documentation. To do a security review in a cost-effective manner, which is the reason I'm here, is there needs to be traceability between the functional description, what you're wanting to do, the high-level design, and then from the high-level design down to the low-level design, which for software is essentially your source code. It is important in a document other than the source code to capture your design philosophy. We need overall architecture, pictures are nice, and some sort of explanation for why subsystems are there, why modules are there, why they're called, and without having to go through the source code and understand that. Let us understand let us develop some expectations up front, and then as we go through, we'll understand what's written there. And as I said earlier, developing alternatives considered is benefit to the developer community more than the assurance community. Also, and this is significant in the comments in the source code, is if you're doing protection, like balance checking, make sure that comment's in the source code. And then there are some tools that can highlight that. What are some of the tools that are available for creating developer documentation? Obviously, some of the easiest one are text. On the Mozilla site, they have essentially a white paper that describes the design. That is an effort. You may not have the desire, the inclination, the writing skills, whatever term you want to use to produce a document like that. Where I think we need to focus on is the source code comments, and especially making source code comments that a parser will recognize, that will be able to pull those comments out and put them in a separate document. So you're having your documentation in one file, and then if someone wants to dig in, they can see that in the source code in another file. Flowcharts for certain programs. UML diagrams, I have 3 types of them listed here. What are your classes that you're using? How are they called? What's the sequence? And how do they interact? And then for some unusual, I I couldn't find a case, but this is type of design documentation. Finite state machines and state charts, they're somewhat related for some very specific cases. I've seen people describe that as a technique to show error cases. But for an overall software, and the major design document, that's probably heavy for most solutions. This is an example of a picture that would help someone begin to understand what the code is doing. This comes from one of the earlier versions of Password Safe. This picture is in a document that was written by Andrew Mulligan while he was in graduate school. And the good news is he's now a developer on the Password Safe project, which is, I think, the perfect situation. And he goes through and comments and says that what you see here is a design that basically keys events off a GUI, and although this might be good for initial, it's not good for a long-term solution. And for those who use Password Safe, you probably saw a big difference recently when they went to the new version. And those included his changes. I don't want to get into changing the design of the software. What I want to do is show this is an example of a picture that lets me know what are the pieces I would expect and how do they interact. Okay. I'm not the devil's advocate. I'm actually here to defend the devil's advocate. I talked to a developer in the commercial industry about this issue who agreed, software development is software development. We have the same problems. We just have the ability to choose different ways to solve it. And he made the argument that commercial developers are going to solve it first. And I want to try to counter some of that. Actually, I'm going to counter 2 out of 3 at least. He emphasizes that the commercial developers are market-driven to develop the code correctly. There is a grain of truth to that, but there is a body of evidence to suggest otherwise. In the market, you have people's salary, professional reputations may come into play. But in general, the market pace is not driven by technical. In the open source community, the pressure is entirely reputation. You publish crap, people will recognize it for crap. And so if there's a hole, your ability to fix that is going to convey to people confidence in whether they can use it. So I think that the open source community is just as capable, maybe more capable, to develop code correctly. Second, if you're paying for software, you have certain demands for reliability. I can't explain it, but I believe those same demands for reliability exist in the open source community, because I see the projects being developed, increase reliability, increase stability. There has to be some motive there, and it's us. We are demanding that reliability. And the money is one thing, but I see our ability to influence the development and increase the reliability is an even match between the closed source and open source. Yes.
A lot of companies sell software support licenses. They get a lot of revenue.
Yes.
Customer success result as a result of the stop paying for the support. So companies are very revenue driven. First, to try to reduce the amount of patches that have to be issued, and second, to deliver patches that work and are put out as quickly as possible. So there's some truth to the argument that they need to deliver the correct code. The problem is that they don't deliver the documentation as I mentioned earlier. That's
Yeah.
the case.
Okay.
Sorry to have to do this, but this is that problem.
Yes, that's okay. And the last is one that I don't know if I can argue, and that's the requirement to make the code approachable. If you dig down in the file that's on your CD, you'll see the actual language used, which it may be cleaned up a bit. But essentially, everybody has their own perspective. If you're the one-person developer on a piece of software, your perspective may be you don't understand why everybody else doesn't understand it or doesn't understand how to use it. And therefore, when someone says, you need to make your software more approachable so that we can look at it, maybe use it, you may be resistant to that. Obviously, that's personality dependent, and I don't know if the commercial world has an advantage other than the market forces to be able to keep their software updated to make their code any more approachable than we do. Path ahead. What I see happening is for the larger projects or more significant projects, they are doing more developer documentation. They have bought into the concept that for the project to survive, we need to capture why that code is there. The OpenSSL project is actually a special example for me. For those who support cryptography in the government, you may have heard of FIPS 140. It's basically an evaluation program, or validation program, excuse me, that allows the use of cryptographic items. OpenSSL would be the first open source solution validated source code level as opposed to the binary level. I mean, this is huge because now you're not having to validate every different version that's compiled, which is what we had to do in the past, or what the people representing projects had to do in the past. If you go to the OpenSSL website, you'll see the effort that they've had to undergo to go through that process. It's not trivial, but it is not trivial for an open source project. It is a lot easier to support if you're in the commercial world, because you can have the marketing person say, I can't sell this to the government until it's validated. And then the price tag isn't that high of a barrier. It's not like a common criteria evaluation where you're talking 5 to an order of magnitude higher in the cost between a FIPS 140 and a common criteria evaluation. In general, I think there is improved comments in the source code. I know I made that comment earlier about, we're still trying to teach it 20 years later. I think we'll continually teach it because we have new students. I think we may need to look at how we peer review those comments, and that's handled differently within projects. They're human dynamics. Every team is different. I think that if we're going to develop developer documentation, the focus needs to be, as I said, let me back up a second. When I talked about development documentation, I talked about traceability from the top down. Let's talk about a high-level functional description, then our high-level design, then the low-level design and the implementation. I don't think that we can go out and do it that way, top-down. That's my opinion, and I would welcome it to be challenged, actually. I think that what we need to do is work actually from the bottom up, so that if we start from the top down, we actually have a place to land. And so the focus needs to be on making the comments in the source code that reflect the design decisions. And the reason is that's where we're working now. We're in the code now. You're not asking for a new document. I'm just asking to improve the documents that exist now. The other thing is the tools are available now to help document what's in the source code, to parse through the source code. Java Docs is the example that I was introduced to, is able to pull that up and pull it together. And so we're not having to talk about wrestling with some sort of drawing program to create UML diagrams. It's relatively straightforward. Learn a few tags, and all of a sudden you can create a set of documentation without a significant increase in effort. And as I said, I think the effort needs to be driven from the bottom up. Kind of wrap things up. What I don't know. I don't know how to motivate the folks who are developing code to write more documentation. I've heard the arguments before. We're commenting the source code. Now we're having to create a user guide, and now you want me to create a document that no one but me is going to use. Well, the answer is yes. I do. I want that, but I don't know how to motivate people to say that. If the software is a security solution like password safe, someone may need to have some degree of confidence in it. It's more important than some other solutions, at least to me. That's my bias, of course. The other thing, and this is an important issue, is I don't know how much documentation is enough. I also think the commercial world has that problem. But I do have a theory on how to determine how much is enough. and I'll get to that last. What I do know, tools are available. They vary by quality. They vary by ease of use. But in general, if they, as with all things, people start using, they provide comment, and the tools will improve to what we need. I believe this community is going to solve the problem better than the commercial world, and that the lessons from this community will actually be brought into the commercial world as best as they can. So I think it's our opportunity to direct different ways of handling it back. And the advantage we have is, of course, is the open, that's a significant piece, exchange of information. We're able to say, this is a bad design, and someone says, okay, it stunk. And we're able to move on from that point. It's different than a proprietary development environment where that may be a closed community, and that conversation doesn't live beyond that moment. Feedback priorities, that deals with how much documentation is too much. As I said, there's two communities that can benefit from the development of documentation. It's development team themselves and then assessment groups. So how much documentation is enough. The way I would determine that is, what does the team need? What can the team benefit from? And the view that you have to have is, if we wanted to accelerate bringing someone on board to help, to bring someone onto the team. The second piece is, if your solution's being looked at, incorporating some of those lessons learned from somebody conducting some sort of assurance review, and letting that kind of guide what is enough. I certainly think that what common criteria is looking for is heavy, and prohibitively so in a lot of cases. And so we need to be able to, I'll use the term experiment, find out what works and what doesn't, and then share those lessons learned. Okay. I'll open the floor to questions. Yes?
Do you have any comments or impressions on the OpenBSD method?
No. I'm aware of it somewhat, but I'm not current. My education isn't current, so I don't want to say the wrong thing, which I could. Yes?
I was wondering whether on the development documentation you talked about is just a way of making code approachable, so that what your intent is to line by line code review after reading the development docs, or how does that flow into, okay, there's one group of people that have an acceptable level, and then maybe common criteria, and you got to 140. Your average desktop user might be something totally different. I just asked the idea of I would love to do analysis and the automatically run when I close on an email. It's a lot different than
Okay. Let me summarize your question and see if I got it correctly. And that's basically, what's my intent with this development documentation? And that goes back to the development of what the term I was taught was abuse cases and how to refute those. In the example with Derek's boot and nuke DBAN, it's possible that someone could write a utility that rather than wiping the disk, they actually encrypt the information with their key or some way to hide the key. So that if all you're doing is, when you're done wiping, you verify there's just garbage on the disk, the encrypted traffic would look like garbage. And then, somebody waits at the sales where they're getting rid of defense equipment or government equipment or healthcare equipment, and then buys up the hard disks and see if they have some information on it. You get one of the Simpson-Garfinkel papers written again. So what I would look at is, how do I know that it's actually wiping it versus then reading, encrypting, and then writing it back down? And so I look at the developer documentation, I find out where that process should be, and then I go and look at it and see how it's executed. So I'm not having to look at the whole code. DBAN's a wonderful example for this, because the piece that is really DBAN is really small, but it sits on top of a bootable CD or a bootable floppy. And so if someone hasn't looked at the software that makes up that bootable floppy or bootable CD, guess what? Everything is in scope. You have to look, you have to follow it through, and there, at that point, and still is, no development documentation to guide you down the path to verify that. Yes?
Yes. Have there been any objective studies of the relative likelihood of vulnerabilities being exploited on commercial software versus comparable open source software?
I don't know. Let me repeat the question. Has there been a study of the open source versus proprietary software and the ability to exploit the different versions? You know, is there a different rate?
Vulnerabilities are actually exploited.
Or how they're exploited, I guess is more correctly.
How frequently they're exploited.
Or how frequent? Okay. How frequently vulnerabilities are exploited is the metric, and you're comparing open source versus proprietary software. And I'm not familiar. I can't pull up a study off the top of my head. Yes, please.
Yeah, just that'd be fun. This all sounds good, and I'm just saying this is a practical sort of sense. Just given the only reason why I've ever come in and code is just so that I don't, 6 months down the line, I'll know why I did that. But documentation takes at least as long as actually writing the code. I think sometimes longer. This all sounds nice and good, but practically speaking, given that a lot of coders, they pride themselves in the fact of making code obscure. The more obscure, the better. How do you think practice is ever going to get implemented?
The thing that has to be looked at, I understand that. That was exactly the impression given to me by the one individual who had reviewed my presentation before I came here was, well-commented code is enough. That's all you ever need. And all I can say is people who have done a lot more software development have written that if you don't have that design captured and the comments aren't in the source code so folks can understand that when you have to go back and fix something, you will spend longer fixing it than you will have if you had written the documentation in the first place. And, I mean, that's the real advantage. You have to we may have to run into those situations where it's a teaching point. You had a hard time fixing that, didn't you? Well, it might have been easier if we had the documentation in the first place.
Let me mention again, in the
Yes, sir.
software world, a lot of companies have a development process with a high level of requirements driven by marketing. Engineering then writes a very detailed design document. And that design document gets reviewed, gets the requirements, and for its own internal consistency before people start to write code, at least in theory. And so,
Yeah.
QA people, I did not mention QA, commercial companies, most companies do have quality assurance groups. They do look at all the documentation in order to understand how to QA the code. And if they don't have what they need, they can shut down the project, regardless of the marketing wants. And they will shut down the project or shut down the schedule until they get the information they need to properly QA because their names are on the line as much as anybody else. I'm yet to hear about a formal QA process in open source, although I didn't hear that.
What company do you work for? Because
Well, not now.
Okay.
I've worked with large companies like Sun,
Okay.
smaller startup companies in Silicon Valley. So I've seen all sides of Europe.
Okay. I mean, let me just answer with a point is that in the open source community, there is no QA group that would prevent you from publishing. I mean, I actually look at that as an advantage. If we had that as a separate process, then all of a sudden you could say, okay, that's great. If people who are looking at code and reviewing it, I'm not just talking about finding exploitable vulnerabilities, but actually doing a review that is somewhat comprehensive, were to publish that and make that more open, that would be great. There was an attempt to try to create that. I don't have my notes with me. And that effort, oh boy, I can't remember the name of it. All right. No. Let me okay, I can't remember the name. There was a website that was going to collect vulnerability assessments, reviews of software. And essentially what happened was they shut it down because they couldn't get funding. They couldn't get funding because the only people writing reviews were a few graduate students of one professor at one university. We're obviously not ready for that. Otherwise, it would have happened. So, and I don't know how to get to that point. But that would be really nice, is to have a body of documentation of people who are looking at code comprehensively and saying, this is what I looked at, and these are the results. Yes?
I think maybe the question we should ask is, what are the acceptance bodies, common acceptance bodies for open source software right now? Right now, they're mostly distro groups like Red Hat and whatnot. What are their acceptance criteria for the software they bundle? It has the same thing Microsoft
Having a solution like that would do wonders, but that's going to apply for the things that would get bundled with an operating system, and that's the only limitation. But I think that's a good concept for that. Yes?
I'd like to say that, most programmers should be self-taught. Any people self-taught. Self-taught documentation style isn't common. In reality, you need concrete examples of documentation work and the process of it through. I've been researching and almost nothing then. There's a lot of little anecdotes, little processes, but nothing is very complete and explains the whole thing. I really can't write documentation until somebody helps me on how to get started on that.
Okay, and what we may want to do is revisit at least my impression of an earlier situation, and that's with user guides. A lot of programmers out there, when it comes to explaining how to use their software, the English skills, they're not as well as their coding skills. I guess that's the right way to say it. Does that play enough? And so what happened? We didn't stop writing user guides. We found people in the community whose skill was English who would work with this programmer and translate it. Well, maybe what we need to do is open up and say is, are there people out there who aren't necessarily programmers but might do, more focused on vulnerability assessments, on architecture, on just general discussions. Open up the body larger than just being a programmer. You don't need to you don't need to have some sort of programmer badge to participate. And there are no bars that I saw. I mean, there's a lot of projects out there when you go through SourceForge where you'll see team members and their roles are identified. Some of them, program manager or project manager. You got developers, you have documentations, you got test specialists. Lots of people have different labels. This may need to be another label. This may be something where we have some people try and then just open it up and say, hey, comment on this. Find people who have experience doing this documentation and saying, how does this work? Yes?
All right, so in terms of using documentation to verify a program, what happens if the developer comments one way and the developer another?
Okay. Let me go back to my methodology, which is I'm going to develop what I call an abuse case and say, this is what I think the program could do. And then what I have to do is go through the design documentation, which really just aims my review. And then the end result is I'm going to look in the source code and make sure that it's actually implementing what it claimed to implement. And the quality of that review is obviously going to vary by the skill of the reviewer. My expertise is at the higher level, developing the abuse cases, not at the lower level. Is this were there any holes in how this was programmed? Okay. Yes.
Final comment on tools that are available. I know that at least on the Python side of the house, there's some very good tools. One called Python allows you to embed what's usually called limited programming into your document. You can write into the code so you can extract it out of the document.
Yeah. Okay. That's good. The other site that gave me a tremendous list of tools is a tool called Doxygen. They have a list on that website of both the non-commercial and commercial tools. As I said, I'm convinced that the tools are there for the beginning steps. But obviously, we need more practice working with it as a refinement. One last question. Okay. Getting ready to get kicked off the stage. Let me make a shameless plug for Geekwares. If you like this T-shirt, $10 in the vendor area. The vendor area is going to be closing at 3, so if you have any final purchases to make, please do so before 3 o'clock. Also, going to be a reminder that the DEFCON surveys will happen in this room at 4 o'clock with very fun amount. Boy, I'm not remember. We need everybody to exit the room to my right. We cannot have people exiting that way as we have a very long queue for the next presentation.
Hence, if you'd like to see the next presentation, we are asking that you exit. Also, I spoke incorrectly about the Credit Card Networks talk going on in Pelican on next. That talk,
Let me get off the stage and I'll...
okay, no, that talk is at 3 o'clock. The Credit Card Networks talk is going on. So, I said it wasn't, I said it was being replaced, I was incorrect.